Now we are talking about exponential growth and exponential decay. Um, what is exponential growth? Well, imagine you have a savings account, and in this savings account, you were able to put in $500. Now, the percentage on it is something crazy like 5%. There's 5% interest on it. 5% of 500 is, I don't know, hold on. Okay, 5% of 500 is $25. So at the end of a year, if you don't take any money out, that 500 is now 525, right? Now the next year, it's not 5% of 500 anymore, it's 5% of 525. So it goes up by a bit. And then the next year, if you don't take any money out, it goes up by another bit. And it goes up by a bigger bit each year because it's taking a percentage of a bigger number. And that's why it becomes exponential, because it keeps getting bigger and bigger and bigger and bigger. So the function for this, the actual like formula, is a of t equals little a 1 plus r to the t. Where, okay, so where 1 is 1, r is the rate, t is the time, like measured in years, and then a is the principal, the amount that you start with. So you would do, like if they gave you 5%, you would do 1 plus 0.05, 1.05 to the t, to the, say it's 5 years, then you would raise it to the power of 5, and then you would multiply it by the original number. So using that first example, let's say you started with $500, 1 plus 0.05. After 11 years, let's say, I just picked 11 for the sake of 11, how much would that be? Well, let's see. I need to grab my calculator. Scientific version. Okay. So let's see here. We need 500. No. We need to start at what? This is a great video, Mr. Soda. Great content you're making. 1.05 to the 11th equals 1.71 and a bunch of decimals. And I'm going to multiply that by 500. And it ends up being 855. Is it going to focus? 855.17 cents. So that $500 becomes $855. Fun experiment. We're going to take the same interest, same amount of time, but this time we're going to start with $1,000. Okay. So that's 1.05 for the interest rate of 5%, raised to the power of 11 for 11 years. And then we're going to multiply that by 1,000. Now, when we started off at 500, we ended up with $855. We gained $355. If we start off with 1,000, we gain $710. So the more you start off with, the more you earn. Okay, that was exponential growth. Let's see what their example problem is. A business invests $3,000 in a savings account. The account pays 4% annual interest, which means we're going to multiply by 1.04 because it's 1 plus the rate. How much money will be the account after 5 years? So this is what the formula looks like. $3,000 is the principal. 4% is the interest, so it's 1.04, and we raise it to 5 for 5 years. Let's see, 1.0. What did I say? 4 to the fifth. Multiply that by 3, 1, 2, 3 zeros. 36.49.96 cents. 36.49.96 cents. That's good. We follow up exponential increase with exponential decay. And it's virtually the same formula. In the other one, it was 1 plus r. This one, it's 1 minus r. Because it's going down. So let's say what their example is. You buy a new phone for $950. Let's see. The value of the phone decreases by 4%. 1 minus 0.04. Every year. How much is the phone worth after 6 years? Okay. So $950. That's what? That's an iPhone 1 generation ago, right? So let's see. 1 minus 0.04 is 0.96. We raise that to the power of 6 for 6 years, and it's going to be worth about 78% of what it was worth when it started. So we multiply that by the 950, and it is now worth 743.62 cents. Just to show you how I did that, it was 1 minus 0.04 got me 0.96. 0.96 to the power of 6 got me 78%. 78% times 950 got me 743.62. That's how all these are going to work. You start in the parentheses, move to the exponent, then move to the main thing. Start in the parentheses, move to the exponent, then move to the main thing. Okay?